We are rapidly approaching a threshold where the global population of AI agents will outnumber the human population. We are looking at a future with billions of digital entities operating constantly in the background. We are all familiar with current AI models like ChatGPT. They are incredibly intelligent, but they are structurally passive. They wait for a command, execute it, and then stop until they are prompted again. Take a traditional pizza chatbot. You ask for your usual large pie. If there is a massive snowstorm outside, the chatbot will flawlessly process your payment and submit the order, completely oblivious to the fact that deliveries are delayed by 3 hours. The system fails here because traditional AI only possesses deep language comprehension. It can parse your grammar perfectly, but it has zero awareness of the physical, real-world environment surrounding your request. To achieve true technological integration, we have to move past systems that simply converse. We need systems that analyze situations, adapt to the context, and take action independently. This diagram shows the foundational architecture of an AI agent. At the very center, you have the core processing engine, the large language model, acting as a central hub. The function of this engine is intent recognition. It takes unpredictable, messy human phrasing, whether you type "get me a pie" or "I need food," and translates it into a single, actionable command category. An AI agent expands this core by integrating an external tool arsenal. These modular nodes, like a live weather API, web search, and a historical customer database, plug directly into the engine. These tool integrations act as the system's sensory organs. Instead of being trapped in a vacuum of text, the agent is continuously fed live, dynamic data about the outside world. By combining that initial intent recognition with a steady stream of live environmental data, you create the mechanical foundation required for true situational awareness. Let's return to that pizza order. Imagine it's Friday night. You ask for your standard large veggie pizza, but tonight the local temperature has dropped to below freezing. In a traditional programming paradigm, a developer would have to write hundreds of specific lines of code, a giant set of if-then rules, explicitly instructing the machine to suggest hot soup whenever the temperature drops. Looking at our diagram, the agent pulls your order history and the current temperature simultaneously. Because the underlying language model already understands the human association between cold weather and hot food, it bridges these data points itself. It generates an unprompted output, suggesting a side of hot tomato soup. The system formulated its own conclusion. The developer only provided the tools and the general instruction, "be a helpful waiter." The specific decision to offer soup happened inside the neural network, rather than being hard-coded in Python. This remarkable capacity for independent problem-solving, taking action without an explicit human prompt, is the defining characteristic of agentic AI. Total autonomy introduces immediate operational risks. Left completely unchecked, an AI trying to maximize customer satisfaction might decide the best solution is to simply give away your entire inventory of pizza for free. To mitigate this, developers using frameworks like LangGraph employ a constraint concept known as the leash. In this visualization of the leash, the system has complete freedom to think and explore within a strictly defined geometric radius. Inside, it executes low-risk proactive actions. But when it attempts a high-risk action, like authorizing unsanctioned financial discounts, the architecture aggressively blocks it. This architecture allows for the deployment of autonomous digital employees that can solve problems without needing manual step-by-step instructions for every possible scenario. As AI agents populate the workforce, the primary human skill will transition from directly commanding machine actions to architecting the boundaries in which they operate.